Hi, my name is Hugh, and I'm going to talk about the Valco valves that we very commonly install in SRI GCs. So a Valco valve looks something like this. They come in a variety of different flavors. This particular one has 10 holes around the periphery of the valve, so this would be called a 10-port Valco valve. Now the Valco valve lives in the GC in this little valve oven. So here's the valve, and then down below where you can't see it is something to turn the valve automatically under the control of our Peak Simple software. For GCs that don't have room for this valve oven, like our smaller sized Model 310 GC, a similar Valco valve can be mounted on the side of the GC, but of course it's not heated. So we have the two different kinds of actuators that turn the same valve. It's really the same valve in the two GCs. It's just a question of what kind of a motor it is that turns it under the control of the software. So in the bigger GC, the 8610C, the motor that turns the valve is only visible if you look inside the GC from the bottom. And here you see this motor that's mounted inside the GC. It's a tight fit, but it does fit. So this is what the whole assembly looks like. You've got the valve, and then you've got this motor that turns it under the control of the software. So what's in the Valco valve, what's inside the Valco valve is something called a rotor. So to get access to the rotor, you remove this knurled nut, and then inside you see this part that looks like this. So the way this works is there's 5 little grooves machined in this rotor, and the grooves line up with the holes. So in this case there's 5 grooves and 10 holes, so one hole here is connected to that hole there by the internal groove. When the valve turns, the little groove turns, and then this hole that used to be connected to that hole is now connected to the one on the other side. And this happens with all the 10 holes around. They shift from being connected to their left-hand neighbor to their right-hand neighbor. So this gives us the possibility of creating many different flow paths inside the GC, which is one of the things we do in order to be creative in how we solve analytical problems. So sometimes we'll plumb this valve up one way, and sometimes we'll plumb it up a different way. But most of the time there's something called a loop. So the loop is a piece of tubing that's connected between 2 of the holes in the valve. And a loop is really nothing more than a piece of tubing that has a certain length and a certain inside diameter, so therefore there's a certain volume inside the tube. Typically we use 1 milliliter as the volume, but you can go down to smaller sizes and up to larger sizes, but typically it's a 1 milliliter loop. So what happens is when the valve is in one position, you pass gas in through the valve, through the loop, and then out the other connection. On the bigger GC, there's a fitting on the front of the GC, but inside it's connected really the same way. It just goes in here, through the loop, and then back out the exit. Then, when the computer tells the valve to rotate, the carrier gas pushes what's ever in the loop into the column. That's how it works in the most simplest of the ways that we plumb up the valve. But we plumb them up in some much more complicated ways, and what we usually do is we put a little map on the top of the GC's valve oven to show you how exactly we've plumbed this valve, so that you can follow the path that the gas takes in the 2 positions of the valve. There'll be a map that shows you the flow of the gas in the load position of the valve, and then there'll be a map below it that shows the flow of the gas in the inject position of the valve. So this lets you kind of follow it with your finger and figure out where the flow of gas is, which is important sometimes in troubleshooting the GC or in understanding how really the whole thing is working. So there's another type of a valve called a multi-position valve, and that looks like this. And you can see on this valve that there's many more than 10 holes. In fact, there's 22 holes in this particular one, and we call this a 10-stream selector valve. So that's a little confusing because we have a 10-port valve that only has the 2 positions, and then we have a 10-stream selector valve that has 10 streams that come to one common outlet. So here's the control for this. So if I want to turn this valve to position number 2, I just push the button and it jumps to number 2. Push it again, jumps to number 3. If I want it to go all the way back home, I hit the home button and it goes all the way back to position number 1. And we use these in conjunction with the 10-port valve to set up a system that can, for instance, sample from 10 different reactors or suck air from 10 different rooms, perhaps, in a factory. So this doesn't do any injection of the sample into the GC. That's the function of this 2-position valve, is to actually inject the sample. What this valve does is it selects the stream of gas that's going to go through the loop and then subsequently be injected by this valve. So between the two, you can set up an automated system that can take a sample from stream number 1, run the chromatogram, and then take a sample from stream number 2, run the chromatogram, take a sample from stream number 3, etc., all the way around to 10, or you can stop it short at sample number 5 or 6, for instance, and then go back to the home position, all under the control of the software.